video slider robot, which is made from VEX components, including a VEX microcontroller and VEX structural parts, to slide a camera all around the object being scanned in 3 dimensions. This is using photogrammetry techniques, which what it does is it collects all the photos necessary to do a 3D reconstruction using an application called 3D Zephyr. You can obtain 3D Zephyr demo, which can handle up to 50 photos, free from the web. Here you see it pointing the camera at the object being scanned in the center, which is on a pedestal and a rotating Lazy Susan. And it pauses about 10 or 15 seconds per sight and allows the vibrations to stop. The camera is mounted on a Lazy Susan that's mounted on top of the large video slider robot, and it allows it to face the object being scanned, and it's tide locked by that bar, that metal bar or metal strip. So the video slider robot orbits around the object being scanned, very similar to the moon orbiting around the Earth. And the moon faces the Earth on the same side because it's tide locked. And I'm sort of simulating that the gravitational pull using that bar, and it points the camera, keeps it pointed in the same direction so that it can get good pictures of the object being scanned. Here you can see the DeWalt Drill on top of the chair. It's on top of a stool because I need to be able to scan it at various heights so that I can get 3 or 4 angles, different angles around each orbit of the video slider robot. So the tripod that's mounted on the Lazy Susan is height adjustable, so that I can adjust the height of the camera to about 4 different heights, 1 height per orbit around it, and that'll give me the 3 or 4 angles that I need for 3D photogrammetry. It is necessary to elevate the camera at various heights during the orbits so that it can get multiple angles of the object being scanned, because you need at least 3 angles to triangulate a single point on the object. I'm using a demo version that allows me to take up to 1,000 photos, which you can also download from the site if you give them your email address. You can see the Lazy Susan is held with about 20 pounds of weight to keep it stable. You cannot have any movements of the 3D object being scanned, otherwise you'll get bad results. This is a close-up of the robot. It has 4 LEDs, 2 in front and 2 in back, that indicate when the video slider is moving forward or backwards. It also has 4 bumper switches for safety. The bumper switches also allow you to select different scan modes for this robot. This robot can go both in a circle, and it can also go in a straight line. The algorithms are all programmed in Robot C on a VEX 0.5 microcontroller. This is the legacy microcontroller that's available for very reasonable prices, around $50 on the web. Power for this robot is a 9.6 volt VEX battery. You can also use the 7.4 volt batteries. You need to let the robot stand for about 10 or 15 seconds so it can stabilize and dampen all the vibrations. in order to get good pictures. The other thing you need to do is you need very good lighting, such as I'm using strobe lights reflected off the ceiling. These are studio strobe lights reflected off the ceiling to get good lighting. But you can also use continuous lights as long as they're bright enough and they're uniform. They cover the whole object being scanned with the same light levels all around. Creating a light box is a good idea. You can do that too. Right now I'm just using the ceiling as a light box and the walls reflecting white light. In order to get a good 3D reconstruction, you need at least 200 pictures, but anywhere from 400 to 1,000 will give you even better results, as long as each picture is very well taken. You need to have them well exposed. You need to use manual mode on the camera so that you get uniform settings such as your exposure, your speed, camera speed, and you lock the focus too, so you're not changing the focus constantly. You make sure it's very focused initially, and then you just lock it, and since the camera is pretty much the same distance to the object being scanned, the focus shouldn't change very much as it's orbiting around it. The tripod is held to the Lazy Susan on the video slider robot using just some ties, black ties. But you can also use metal brackets to hold it down as long as you don't damage the tripod. But the way I have it, I can easily remove the tripod when I need to. In this view, you can see a detailed close-up of the large video slider robot. It uses, like I said, the VEX 0.5 microcontroller, otherwise known as the Legacy microcontroller, which is one of the oldest ones, but it's available for very reasonable prices on eBay, say around $50 each, or even less. And then it uses the 4 VEX motors with some gear boxes, 4 gear boxes, to give it enough torque to carry the camera and the weight of the camera and the tripod, as well as move it through the rug, move it smoothly through the rug in a circular path. Outdoors, it can travel on short grass, and it can be used in a linear mode to be able to take panoramas or cityscapes or even landscapes. So you could have it moving in a straight line and taking pictures of, let's say, the skyline of a city. And by doing that, you can get great panoramas, and you can also get 3D. You can use 3D photogrammetry to get three-dimensional reconstructions of the city, buildings, if you take enough pictures and you use a zoom lens. Normally, you take panoramas using a wide-angle lens. But you can, with this application, with this robot, you can use a zoom lens and get very detailed panoramas, very high resolution, because the camera can move parallel to the plane of the city, and you can get really great pictures that way. And using Photoshop, you can stitch them together. And also using Zephyr 3DF, you can get fantastic 3D reconstructions. You also see the Lazy Susan that I mounted on top of it that holds the tripod together. And you can see how I strapped the tripod to the Lazy Susan using black ties. And then I tied the rod that connects the Lazy Susan on the robot, the video slider robot, to the Lazy Susan on the pedestal, the bottom of the pedestal, shown here. You can't really see it too good because the piece of wood is blocking it. But there's a Lazy Susan underneath that moves in sync, or is tide locked to the video slider robot. And that's how it steers the camera, points the camera continuously at the at the object being scanned. Here are the results of the 3D reconstruction of the DeWalt drill that I scanned using the large video slider robot that you saw in the video. As you can see, it did a great job. It did a great job scanning it. I can turn it around. It's three-dimensional, and it could be 3D printed. Like, let's say you had a DeWalt drill and you broke the case. Well, you'd be able to 3D print a case with this using a standard 3D printer. You can see all the orbits. I went around the drill 5 times at 5 different heights, and that's what those dots are in the background. Those show the camera positions as the robot was starting and stopping, taking pictures. So this worked out very well. And you can also display a 3D mesh of it. So you know, and you save it as a OBJ file or a PLY file, whatever your 3D printer requires. It even got the printing. It's a little bit out of focus. I could have used more depth of field taking the photos. I probably should have used a higher. I was using around f5.6. I probably should have gone maybe to f10. But to do that, you really need bright, very bright lighting, or because otherwise the picture would be too dark, or you have to use a high ISO. I did this scan with ISO 100 on the camera, and again I used manual settings. I used the ISO 100, and I used an aperture of f5.6, and then I used the studio lights blasting off the ceiling to provide the uniform lighting, and it blasted off the ceiling and also the walls, and that's how I got continuous, pretty good lighting all around it. But you can also use continuous lights as long as they're very bright. And if they're not bright enough, then you have to turn up the ISO, like maybe go up to ISO 1200 or even 3600 if you need to. I've done pretty good scans even at ISO 3600. After that, then the quality suffers. But as you can see, it did a fantastic job of 3D scanning this. Again, the software used is 3D Zephyr, and this one is version 6.006. And this is the full version. I got a demo of it, but I had to send them, give them my email address so that they could send me a key. And this is a 14-day demo that you can use. But they also have the standard version that's free that allows you to take up to 50 pictures. The problem with that one is that 50 pictures is not usually good enough to get a good 3D scan of a complicated object, unless you really, really position the camera well. It's not impossible, but it's very much harder. You really need this scan used around. This was around 250 pictures that it used. And like I said, it did a phenomenal job of 3D scanning it. This is all I have for today. Thank you very much, fellow patrons. Until next time.